Anything that rotates keeps on rotating until something stops it. Angular momentum is defined as the product of rotational inertia I and rotational velocity omega. Angular momentum equals I times omega. Like linear momentum, angular momentum is a vector quantity and has direction as well as magnitude. For the case of an object that's small compared with the radial distance to its axis of rotation, the angular momentum is simply equal to the magnitude of its linear momentum mv multiplied by the radial distance r. Angular momentum equals mvr. This applies to a tin can swinging from a long string or planet orbiting in a circle around the sun. An external net force is required to change the linear momentum of an object. An external net torque is required to change the angular momentum of an object. Angular momentum is conserved for systems in rotation. The law of conservation of angular momentum states that if no unbalanced external torque acts on a rotating system, the angular momentum of that system is constant. With no external torque, the product of rotational inertia and rotational velocity at one time will be the same as at any other time. When the man pulls his arms and the whirling weights inward, he decreases his rotational inertia and his rotational speed increases. The man stands on a low-friction turntable with weights extended. Because of the extended weights, his overall rotational inertia is relatively large in this position. As he slowly turns, his angular momentum is the product of his rotational inertia and his rotational velocity. When he pulls the weights inward, his overall rotational inertia is decreased. His rotational speed increases. Whenever a rotating body contracts, its rotational speed increases. This applies to stars that collapse. When the star collapses, its rotational inertia decreases and so its rotational speed increases. A falling cat is able to execute a twist and land upright even if it has no initial angular momentum. During the maneuver, the total angular momentum remains zero. When it's over, the cat isn't turning. This cat rotates its body through an angle, but does not create continuing rotation, which would violate angular momentum conservation. Although the cat's dropped upside down, it's able to rotate so it can land on its feet.